Hello everyone and welcome to today's webinar about the exchange model between advanced design and Revit using PowerPack. My name is Evelina Palkanoglu. I'm Solution Technical Specialist in Greytech for Advanced Design, and I'm also a structural civil engineer. Today, we will see how to upgrade your BIM workflow using the excellent synchronization between advanced design and Revit. However, before going into details, it is important to explore together the concept of BIM and how important this is for civil engineers today. So BIM stands for Structural Building Information Modeling. BIM is the process of creating a digital model of a building's structural components by using a specialized BIM software. The primary goal of BIM is to create a comprehensive three-dimensional representation of the building structure in order to facilitate the communication, coordination and collaboration between the various stakeholders involved in the design, construction and maintenance of a building. Why BIM is significant? Here you can find 4 different reasons why BIM is very important. First of all, it enables architects and engineers to create a more accurate and detailed representation of a building structure, reducing errors and improve overall design and accuracy. BIM can enhance collaboration, allows stakeholders to collaborate in real time, share data, and identify potential issues before construction begins, reducing costly errors and delays. BIM also provides better project visualization. BIM models provide a detailed 3D visualization of a building structure, helping stakeholders to better understand the project and identify potential issues. And the fourth reason, the efficient construction process. By using BIM software, stakeholders can create a more efficient construction process, reducing waste and improving overall project delivery. Based on these statistics, BIM workflow is a very powerful tool for architects, engineers and contractors, since it can save time, reduce the errors when it comes to data sharing, and also reduce any construction costs as well as rework. In this webinar, I am going to focus only on BIM workflow between Revit and advanced design and how this can be successful using the PowerPack. 2 concepts will be introduced during this webinar, the physical and the analytical model. Normally, physical model is the model created in Revit, whereas analytical one is the one that is identified by advanced design, analyzed and designed. Here are some examples of a physical and analytical model of the same structure. The main difference between a physical and analytical model is obviously on the analytical model, all the elements are structural elements, whereas on a physical model, some elements can be non-structural ones. Another example of a physical and analytical model, the physical one on the left-hand side and the analytical one on the right-hand side. A few key points about the analytical model. The analytical model improves the flexibility and the collaboration, and obviously the analytical model can be independent of the physical model. How you can generate an analytical model when you already have a physical one in Revit? Using the PowerPack and selecting the option structural, a pop-up menu is created, and you can select the option create analytical model or automate analytical model. In this case, the physical model will be created, will be transformed into an analytical one. An analytical model can be created in Revit without a physical model first, which means that you can create a physical model in Revit from scratch. So using the analytical member functionality of Revit and using the draw options that Revit provides, you can create an analytical member which ends up in an analytical model after all in Revit. An analytical panel can also be created in Revit as well. So an analytical panel is going to represent a structured wall, a floor, or a panel, and the shape can be changed by adjusting the nodes and the edges or editing the boundaries of this panel. And also an opening can be analytical in Revit as well. So an analytical opening can be created in an analytical panel by using the opening tool by face. Here are some examples between analytical and physical members when it comes to their properties. So selecting a member on a physical model, the property section is going to look like this. You get information about the section of the member, the base level, the top level, generally about its geometry. When it comes to an analytical one, selecting the same member, you will end up getting information about the material of this element as well as about its structural role. Analytical automation is the functionality of Revit in order to create a physical model from an analytical one or vice versa. As we will see later on the demo, having one of those two, you can always create the other one in Revit, and this is basically enables the synchronization between Revit and advanced design. In other words, you have the physical model in Revit, you transfer this model to advanced design by creating the analytical one of this model. Advanced design analyzes the analytical model, and then this analytical model is transferred back to Revit and it is transformed into a physical one. And this is pretty much what this figure explains. We can see now in a short demonstration how the transfer between Revit and advanced design can be performed. This is a physical model created in Revit, and you can see that there is some loading applied to this model as well. Using the Power Pack, I am going to create the analytical of this model, and I will transfer this model to advanced design in order to analyze it, design any of those elements, and I will transfer this model back to Revit in order to perform a whole cycle of synchronization. So having installed the Power Pack and selecting the option structural, as you can see here, there is the automate analytical model option. By selecting the whole model, and selecting the automate analytical model, an analytical model of this physical is going to be created. And by hiding the physical model, you can access the analytical model of this physical one. By selecting any of those elements, you will be able to see that this is an analytical member and see the structural role of this member. For example, this is a column. By selecting this, you're going to see that the structural role of this is a beam. The transfer from Revit to advanced design can be performed very easily. Either selecting the advanced design icon on the ribbon or the beam connect icon and the option export. I am going to go with the advanced design option. Both options are the same. They both end up creating a model in advanced design. The transfer from Revit to advanced design has been performed effectively. And this is the structure exactly as it was in Revit, now in advanced design, and is ready for the analysis and design. All the structure members that have been defined in Revit are now in advanced design. Anything that has not been identified as a structure member is not transferred to advanced design. Another important comment is about the levels and the elements that correspond to its level. So the advanced design can identify all those levels defined in Revit and can create those levels in the structure tree. And the model is pretty much ready for the analysis and design. The only thing that needs to be done before running any analysis and design is to create the combinations, because the requested combinations from Eurocode cannot be defined in Revit. So this needs to be done in advanced design now. Generally, in case there are any errors in the modeling of this structure, there is the check control in advanced design where you can check if there is any member that is not connected properly to other members. So normally, before running any analysis, I prefer to check for any warnings or errors, generally when I transfer models between softwares, just in case something has been missed and may cause an error in my analysis later. Hopefully there are no errors, which means the design of the creation of the model in Revit was absolutely fine and correct. So now I'm ready to run the analysis and obtain the results. The analysis and design of this model has been performed. We can now see and post-process the results, and we can transfer this model back to Revit so we can see a complete cycle of synchronization between those two softwares. I'm going to plot the bending moments for this model. And in order to transfer the file from advanced design back to Revit, we need to export this file as a GTCX file and import it in Revit using the following procedure. An important comment here is that normally the file needs to be uploaded in a new file in Revit, because this way we can manage not to have any overlap between members. You can export the GTCX file using this functionality here, where you can name your file and save it as a GTCX file. Using the Power Pack functionality of Revit and the BIM Connect, we import the GTCX file we just created from Advanced Design. We have some options here to keep the internal forces for linear members or the resultant forces for walls. It depends on the user, what they want to have or not. I will keep the default options, but as I said, it's the user's option after all. You select the file, and all the structural members are now imported from Advanced Design back to Revit. Normally, it takes a few seconds, and the transfer is effective. You can generate a report if you want to. The report pretty much explains and gives some information regarding the members that have been transferred. And now, by selecting the 3D view, you can effectively see the analytical model as it was calculated from Advanced Design back to Revit. We can also access the results created from Advanced Design using the synchronization functionality in Revit. By selecting the file we would like to synchronize the results. The results are available on a structural analytical model ribbon on the structural analysis. By selecting Results Manager, we can check that they are up to date. And then by selecting Results Explorer, we have the option to select any of the parameters, such as moments, forces, and plot this parameter in Revit. So now, a full cycle from Revit to Advanced Design has been performed, and this pretty much summarizes the synchronization between those two softwares in order to create a very good BIM workflow. So you have a model in Revit, which you can transform this model from a physical to analytical, import it to Advanced Design, analyze it, design the members, and then transfer this model from Advanced Design back to Revit in order to keep changing any members that you would like in terms of the not in terms of the design, but in terms of the architectural design. And you can perform this cycle as many times as you wish. Describing the synchronization between Revit and Advanced Design and explaining a full cycle of transfers between Revit and Advanced Design, we can now say that these two softwares can be a very good example of a good workflow. A few conclusions before closing this webinar for today. The analytical model is now a very important concept in Revit in order to enable this synchronization between these two softwares. So now all the work can be done in Revit. You can create the analytical model in Revit, so you don't have to do anything when this model is transferred in advanced design. And of course, the second conclusion is about the BIM. Connect is a very efficient tool in order to export, import, synchronize any data, any type of data and results coming from both softwares. So this tool, along with the Power Pack, can enable this excellent workflow, save energy, time, money, and also reduce the errors between the exchange of data between engineers, architects, contractors, anyone that is working on the construction and structure and engineering industry in general. Thank you very much for your attention. I am happy to take any question from you. Thank you very much again.